Hi, I'm David Bolton of Go Parallel, and today I'm going to be looking at getting started with Intel Trace Analyzer and Collector, or ITAC as it's known for short. It's a graphical tool for helping you understand the behaviour of your MPI application. It lets you eliminate bottlenecks, improve correctness, and assist getting the best performance. MPI is short for Message Passing Interface. It allows a computer program written in C or Fortran to talk to other computers by sending and receiving messages. This can be used to distribute workloads between them. It's an effective way of doing parallel processing on a network of computers, or even on computers that share memory between processors. There have been 3 MPI standards published in 1994, 96 and 2012. The hardback version of the most recent standard is 868 pages long. Building an MPI program is fairly straightforward. If you've never done one before, really all you need to do is to add an include of mpi.ht program and set up the include directory and library paths for linking, and then add imp.lib for C programs, and for C++ add imp.lib and impicxx.lib. That's for release. For debug you also need to add impid impid.lib, and for C you need the impid.dll, and for C++ you need impicxxd.lib. You also need to copy the DLLs from the bin folder to where your program binary is located. Then you run your program with the command, the mpixec. We'll come to that shortly. And the first time you run mpixec, it asks for your Windows password, so be sure you know it. That tripped me up as I always use the pin on Windows 10 and I'd forgotten it. To run your executable with mpixec, you need to decide which configuration you're using. These are called fabrics, and you can specify them either in an environment variable or as a parameter for mpixec. As I didn't have another PC handy, I used the share memory fabric. A specified number of processors has sent messages between processes just running in the same memory block. The command line that I used to run the program, mpil ITAC is this. I'll just show you over here. And that's mpixec minus gemv, blah 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 blah, mpi itac.exe, which is my executable. The 4 there is the number of processors, and in this really simple program each process just prints out a text message, hello from 3, etc, etc. You don't need to relink if you want to try a different configuration. You can rerun it with a different number. Finally we can get on to ITAC. One thing I found a bit confusing at the start was that you can compile MPI programs for C and C++ with the Visual Studio Microsoft compiler. But if you want to use Intel of the ITAC, it requires that you use the Intel C++ compiler. That's because of the tracing option. If you're starting down this road, I think it's probably easier just to use the Intel compiler for everything MPI and ITAC. Now, confusingly, a minor bug cropped up after I'd completely installed the latest version. The program correctly compiled in the debug configuration, but not in release. It couldn't find the icl.exe, which is the Intel compiler. And I looked into the environment variables and found multiple versions of the path. I had to clean them up manually. Eventually I got it to build. Because I'd used multi-threading DLLs, it also requires libmmt.lib, and that was another path to add to the link project settings, making 3 in total. Just as a quick reminder, here's how it works. First of all, you build your MPI program, and you can do that in the Visual Studio IDE. You get it running, and then you switch to ITAC to debug it, to find out what's happening. To do that though, you have to switch to the command line and compile using a command called mpiicc. And if we look here, we should be able to see it. This command here, mpiicc minus trace, and then the program. The thing you have to notice there is the minus trace. That's needed for ITAC to do its cleverness. Once you've built your program with the trace option, you run it again. This time it'll be much slower because of all the logging that's going on. For 4 processes, it took 136 seconds. I tried it later with 8 processes, and that took over 10 minutes. After it's finished, you'll be left with an STF file, and that's the input we need for ITAC. ITAC's on your Windows Start menu. It's a standalone program, not something launched from Visual Studio. So let me just show you where it is. This is Windows 10, so click All Apps, down to Intel, Parallel Studio, then down to the Update to, and that's your Intel Trace Analyzer. When it opens, it will ask you for a dialog to the path to the STF file, and once it's opened that, it will produce this screen here. Well, I'm having slight technical problems at the moment, which is why I didn't actually run it. If you look here, you can see that the red is the amount of time spent in the MPI calls, and that's roughly 20%, and the rest of the time, and this is for the 136 seconds, is spent in the serial code, which is all the code running, doing system calls, whatever. Ideally, you want to have as much in the MPI calls make the red as big as possible, but with this program, to be honest, there's not an awful lot we can do to improve it. Thank you for watching this video. I'm David Bolton of Go Parallel, and excuse my voice today, I'm a little bit hoarse.